Hello students, once again welcome you to GK's Applied Maths classes. Today we are going to introduce a new chapter in probability and applied mathematics. So what I am going to do in this video is we will just revise once again what probability is from class 11th, and also do introduce you to probability distribution, and I am going to solve some Cbse handbook example questions, okay, before we go to the exercise. Okay, so let's get into this. Now what is this actually? There are interesting terminologies that you should be very familiar with in probability. One is a random experiment. So what is a random experiment? An experiment is called random if it has more than one possibility, and it is not possible for me to predict the probability, predict that particular outcome. For example, if you want to throw a coin, if you want to toss a coin, it has more than one outcome. What is that? It has head and it can get tail. Now you cannot predict whether I will get head or tail. Okay, and also each one of them have equal probability of occurring. That's a different issue. But it is not, when I toss a coin, it is not possible for me to predict whether I will get head or tail. So such experiments are called random experiment. And for another example, if you throw a die, you can get either 1, 2, 3, 4, 5 or 6. And it is not possible for me to predict what I am going to get. I may get a 5, I may get a 6, I may get 1. So it is not possible for me to predict an outcome. Such experiments are called random experiment. Now that you understood what a random experiment is, the next important word is called the sample space. Sample space is generally all possible outcome in a random experiment. So for example, if I am throwing a coin, my sample space will be what? Head or tail, because I can get either head or tail. Suppose if I toss two coins, so what will be my sample space? I can get both head, or I can get one head, one tail, or I can get one tail, one head, or I can get both tails. Okay, so this is a sample space. For example, if I want to throw a die, all possible outcomes are 1, 2, 3, 4, 5 or 6. So sample space is all possible outcome in a random experiment. I think you are doing it from class 10, so it should not be a problem to understand this. Now next one. What is an event? Okay. An event is a subset of the sample space. For example, I am throwing a die. Okay. I throw a die. So what is my sample space? My sample space is 1, 2, 3, 4, 5, 6. Suppose if I want to get only prime numbers. When I throw a die and I want to get only prime numbers. So what will be E? You know 2 is a prime number, 3 is a prime number, 5 is a prime number. So this is the event. And where is it? It is in the sample space. So an event is always a subset of the sample space. An event is always a subset of the sample space. Okay. Now what is probability of that event? The probability of the event E is number of element in the event by number of element in the sample space. So how many elements are there in the event? Here the number of element in the event is 3. How many elements are there in the sample space? There are 6 elements in the sample space. So what is the probability? The probability is 1 by 2. So all possible outcome in a random experiment is called the sample space. An event is always a subset of the sample space. Is that clear? And how do I measure probability? Probability is defined as n of E by n of S. And also you should know probability is a number which lie between +1 and 0. It always, because the denominator is going to be bigger than the numerator. So the fraction will always be less than 1. Suppose if the probability of an event is 1, you call that event as sure event. Why it is called sure event? Because your E is nothing but the sample space. Okay, and Suppose the probability of an event is 0, E is an impossible event. I'll give a simple example. When I throw a die, what is the probability of getting any number from 1 to 6? Obviously 1, because when you throw a die, you will only get numbers from 1 to 6. Suppose I throw a die, what is the probability of getting a number 7? It's impossible. So that is why that's an example of an impossible event. Is that clear? So probability of an event is defined as number of element in E by number of element in sample space. And don't forget, this probability is a number which lie between plus 0 and 1. If probability is 1, it's a sure event. If probability is 0, it's an impossible event. I hope this is clear to you. Okay. Now I'll just get rid of this. I don't want this. Okay. Hold on. I think I lost the entire thing. Just a second. Now, in this, I want to talk about what is a mutually exclusive event, mutually exclusive and exhaustive event, and what is an independent. We'll cover all this. All this you have done in class 11th. Okay, just as an introduction, I just want to go back and see what you have done in class 11th. Now, I'll take an example. Okay, a die is thrown. A die is thrown. So what is my sample space? My sample space will be sample spaces 1, 2, 3, 4, 5 and 6. So this is my sample space. Now I'm going to define two events, E and F. Okay. The first event is, say, I'll take 1, 3, 5. The next event is, for example, I'll take 2 and 4. This is one example. I'll take another example where I take E as 1, 3, 5 and F as 2, 4 and 6. I'll take third example, E as 1, 3, 5 and F is, say, 3, 2, 3, 4, 3, 4. Fine. I'll take third example as, say, 1, 3, 5 and F is 2, 3, 4 and 6. Now look at this example. If you analyze this example carefully, this one, these are two events and clearly they have nothing in common. E intersection F is null set. If E intersection is null set, you can say the two events are mutually exclusive. Or otherwise you can say the two sets are disjoint. If I represent E like this, my F I can write like this. Okay? They will not overlap. They don't overlap. Okay? So this is a mutually exclusive event. For a mutually exclusive event, intersection is impossible. So what is probability of an impossible event? 0. And this is the addition law of probability, which you have already done. So what is probability of E union F? Probability of E union F will be probability of E plus probability of F, because probability of E intersection F is 0. So this is how you define a mutually exclusive event. Let's come to this example. Now clearly E intersection F is a null set. If they are null set, what do you know? E and F are mutually exclusive. But there's another very interesting thing. If you notice, if I take E union F, I get my sample space, correct? If I combine E and F, I get the entire sample space. If E union F is a sample space, such events are called exhaustive event. So This is only mutually exclusive because here E union F is not sample space. In this case, E union F is sample space. So I will say E comma F is mutually exclusive and exhaustive unit. So in this case also, since intersection is null set, P intersection F is 0, and probability of E union F will be what? Probability of E plus probability of F. But since it is exhaustive, probability of E union F will be 1. Okay? That we will not go into that. When the situation comes, we'll see. Now what is this? What are these two examples? If you notice, this E intersection F is not null set. So definitely this is a very good example of an event which is not mutually exclusive. Which is not mutually exclusive. But if you notice this carefully, E union F is a sample space. So this is just an exhaustive event. Now how do I represent this diagrammatically? This is E and this is F, and you have 1, here we'll have 3, and it will be 5 here, 2, 4, 6. You see this? 1, 2, 3, 4, everything is covered. The entire sample space is there. Now here you can say probability of E union F will be probability of E plus probability of F minus probability of E intersection F. Okay, the overlap should be taken into account. Now here, if you see, E intersection F is definitely not null set. That means it is not mutually exclusive. But what happens here? E union F is definitely not the sample space. So this is neither mutually exclusive nor exhaustive. Okay. So here what happens? You can again, if I have to represent this diagrammatically, I can write E and F. What is E? E is 3 is common, right? So 1, 5. This will be 4. See, F has 3 and 4 here, but there are some elements left out. So you will have a sample space outside. What is my sample space? 1, 2 is missing, 3 is there, 4 is there, 5 is there, 6 is missing. So 2 and 6 should be represented. Whereas here you don't have to draw that rectangle because E and F itself completes the sample space. So if I combine E and F, I get the sample space. Here if I combine E and F, I don't get the sample space. Is that clear? So here also I can use this formula, that probability of E union F is probability of E plus probability of F minus probability of E intersection F. This is very, very useful. Now the last part is, I want to talk to you about this independent event. Okay. Let us see what independent event is. Okay. Now what is an independent event? Let us take a simple example. Suppose there are two people, okay, apply for a job, okay, and there are two situations. One situation is there is only one vacancy. In this case, there are two vacancies. Then what happens? If two people are applying, let us name them as A and B. Since there's only one vacancy, if A gets the job, B should not get the job. If B gets the job, A should not get the job. So this is a case where the event is not independent. because whenever A gets, B should not get. When B gets, A should not get. So they depend on each other. Such events are independent events. Whereas if you see this problem, it's the same situation where there are two vacancies. Okay, vacancies. Okay, what happens? A can get, or B can get, or both can get, or both may not get. There may be other people who get it. So they don't depend on each other to get the job because there are two vacancies. When A gets, B can also get, or B may not get. When B gets, A may also get, or A may not get, or both of them may be rejected, or both of them can be selected. So this is a simple example of an independent event. Now for an independent event, there is a formula. P of E intersection F is P of E into P of F. Don't forget this. Now you can put this in the formula. Okay. So if a P of in this formula, wherever A intersection B is there, you can write P of A into P of P. That's all. That will satisfy this. Okay. Now with that, I think I have covered to large extent whatever we may require for class 12th. Okay. So from the 11th standard portion, I just covered a bit of it. There are base theorem and other things which is not relevant for us, but that is why the base, the independent event I have talked about. So let us now straight away get into class 12th portion. The most important part of class 12th portion is this word called random variable. Okay, a random variable is generally denoted by the capital letter X, usual notation. What is this X? It's a function which takes set of all sample space to a real number. Okay? Set of all sample space to a real number. Okay? And its range, okay, you can say a range, it will be a subset of the real number. So now let us try to understand what this random variable is all about. For example, let us I have taken an example here. A coin is tossed 3 times. When I toss a coin 3 times, what is my sample space? I can get 3 heads, or I can get 2 heads, or I can get 2 tails, or I can get all tails. This is the sample space. The question here is, I want to know the number of heads. Number of heads. Now, what is the meaning of number of heads? When I toss a coin 3 times, how many heads I can get? I may not get any head. That is what I written here, 0. I may not get. I may get all 0. All will be tails. Or I may get 1 head. Or I may get 2 heads. Or I may get 3 heads. That's all, because I am tossing the coin only 3 times. So this is my random variable X. Now if I have to put this in this language, it's a subset of the sample space. So first of all, let me take the sample space. I divide the sample space into small blocks. What is that block? That block is all tails. Okay. The second block is 1 tail. Head, tail, head, 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 tail. And the third block is 2 tails. Tail, head, tail, head, tail, tail. And the last block is all are heads. Does this complete your sample space? Now you can see for yourself. This is what I meant by assigning values. 0 head, 1 head, 2 head, 3 head. These values exhaust my sample space. So it is a function from sample space to what? We have to find out that. To what? Okay. Now what is probability of getting no head at all? No head means all are tail. So it is 1 by 8. So this will go in real numbers. This is a set of all real numbers. This will go to 1 by 8. So it gets associated to a real number. Okay. Now what is the meaning of P of x is equal to 1? When I say x is equal to 1, I'm talking about one head. Okay. Well, that is, I think I made a mistake here. I'll change it. Okay, it's not a problem. Tail, head, tail, head, tail, tail, and tail, tail, head. So there won't be any confusion. You see, I'll make this as two head, tail, head, 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 tail, head, tail, head, head. Now I think there's no confusion now. Now when it is one head, that is 1, 2, 3, it will go to 3 by 8. Okay, so this will go to 3 by 8. Now what is the meaning of x is equal to 2? X is equal to 2 means 2 head. So this will go to 2 head. So it will also go to 3 by 8. And lastly, all are heads, all 3 are head. So this will go to the number 1 by 8. So now you understand the definition. A random variable is a function. It's a function which takes what? Which takes set of all elements in the sample. So all the elements should be exhausted. If elements are not exhausted, it's a problem. It takes all the elements in the sample space, okay, to a number. Okay. And what is my range? My range is 1 by 8 and 3 by 8, which is a subset of the sample space. That is what is mentioned here. Okay. Now the next word which is going to also get associated with a random variable is called probability distribution table. Probability distribution table. Now what is this probability distribution table? Nothing, it's very simple. It's a tabular column which will indicate two important things. One is your random variable x, okay, and other one is their corresponding probabilities. For example, what is the random variable in this case? It is 0, 1, 2, and 3. And what are the probabilities? 1 by 8, 3 by 8, 3 by 8, and 1 by 8. This table is called probability distribution table. You are distributing the probability in a tabular form. Now, if you notice very carefully, your total probability, sigma pi, if you add all of them, 1 by 8 plus 3 by 8 plus 3 by 8 plus 1 by 8 will be 8 by 8, which is 1. If sigma pi is 1, then you can confirm that x is a random variable. This is an indication that you have not left out any element in the sample space. Suppose x is sigma pi is not 1, then this x is not a random variable. That means it is not a function that has taken all the elements in the sample space to a real number. Something is wrong. Okay. So if you want to know that x is a random variable, if you have to prove it's a random variable, then sigma pi must be 1. So 3 important words that you should know. The first important word is what is a random variable is. Second important word is what is a probability distribution table. And third, what is a condition? If you want to know that x is a random variable, how do I verify? Your total probability of x should be 1. Otherwise, it is not a random variable. Okay. I hope it's clear. Now this random variable is categorized into two types of random variable. One is called discrete random variable. Other one is a continuous random variable. If you see this carefully, this is a discrete random variable because your x takes value 0, 1, 2, 3. That means I am not aware of what is happening in between 0 and 1. Okay. After 0, I have jumped to 1. After 1, I have gone to 2. After 2, I have gone to 3. It's countably infinite. Okay. So you can just see, you can have even any number of terms. But you should be able to say this is the first number, this is the second number, this is the third number, this is the fourth number. So that is what the meaning of discrete is. Okay. So for such distribution, if you are able to count like that, then I will say my random variable x is discrete. Okay. Suppose if I can't tell that after 0 it is 1, if I am not able, after 0 it may be 0.1, 0.01, 0.001, I don't know what is the value after 0. So such random variables are called continuous random variable. If I have to put it on a number line, if I say 0 to 3, if I say 0, 1, 2, 3, this is discrete. Whereas if it is 0 to 3, let me use the marker here. If I take all the values from 0 to 3, it is continuous. Okay. So we are first going to deal with discrete random variable. After dealing with discrete random variable, finally we go for continuous random variable. This is little different from this. Okay. That's what I mentioned here. A random variable is discrete if it assumes only finite or countably infinite number of values. For example, a number of heads. Just now I gave you the example. Non-discrete random variable. What is this non-discrete random variable? Non-discrete or continuous random variable which assumes non-countable or infinite number of values. For example, if you talk about the height of a student in a class, it is not easy to say this is first, that is second. You never know. Okay. So the height of a student in a class is one of the examples, simple example of a continuous random variable. Okay. But we are not going to come to this. We will come to this little later. Now, since I have introduced you, actually the probability distribution, you see, I have talked about probability distribution, right? I have talked about probability distribution of the random variable x. But this random variable x is categorized as what? Discrete. Another one is continuous. Now, discrete random variable with some special conditions, we'll come to those things later. This probability distribution will be called binomial distribution, or you can even call it one more, Poisson distribution. Both come under the category of discrete. Of course, probability distribution is a common name. Okay. But if I put some conditions on probability distribution, you can call that probability distribution as binomial distribution. For some other condition which we will mention later, that probability distribution can be called as Poisson distribution. But if your random variable is continuous, it has only one name, the probability distribution can be called as normal distribution. This is what your syllabus is all about. First, I will talk about random variable, probability distribution. Under probability distribution, we are going to talk about binomial distribution, Poisson distribution, and normal distribution. The moment you finish this, probability is completed. Okay. So I am going to go one by one. Okay. Now, in all this, what we are going to do, we are going to find mean, and then variance and standard deviation. In all this, I am going to find mean, variance, and standard deviation. Now, let me give you the, okay, I'll just take you to the next page. Look at this. This is what I'm talking about. A probability distribution of a random variable x. X takes value x1, x2, x3, xn. There I said 0, 1, 2, 3. And the corresponding probabilities p1, p2, p3, pn. See this table. X is 0, 1, 2 up to n. P of xi is p1, p2 up to pn. If sigma pi is 1, then you can say x is a random variable. Add this, okay? Random variable, don't forget this. Now, it is possible to find mean, median, mean, variance. Okay, now what is the mean? The mean, or otherwise it's called expectation. Mean or expectation of x denoted by mu, or you can denote it as E of x, is nothing but sigma pi xi. I is from 1 to n. Okay. Sigma pi xi. Now what is variance? Variance of x is denoted by the formula sigma pi xi square minus sigma pi xi the whole square. Okay, or in short, some people write this as E of x square. E of x square corresponds to pi xi square, and this is E of x. This is nothing but E of x. You can see it for yourself, the whole square. So these two formulas are very, very important. And finally, you have standard deviation denoted by sigma, which is nothing but square root of variance of x. Okay, I hope it's clear. I think I've written all that here. Okay. Now we are going to solve one problem at a time. Let's see how to go about it. Okay, let's do this problem. Example number 1. This is an example from the NCERT book. Okay, let's see how to go about it. Now, what is the question? Rajat is playing a game of rolling a die with his friends. According to the game rule, he wins ₹5 for rolling an even number, and for getting an odd number, he loses ₹2. X represents the amount of money he wins or loses. So, what is my X? X is the amount of money he wins. I'll keep it as he wins or loses. Okay. So, what are the amount he wins? He wins ₹5, or he loses ₹2. Loses is denoted by -2. He wins ₹5 or loses ₹2. Show that x is a random variable. How do I show x is a random variable? I have to show that the total probability is 1. We'll find out. Now, what is the meaning of P of x is equal to 5? The meaning of x is equal to 5 is he wins ₹5. When did he win? When will he win ₹5? He will win ₹5 if he rolls an even number. So how many even numbers are there? There are 2, 4, 6, and probability of getting 2, 4, 6 is it is 3/6, which is 1/2. And what is P of x is equal to -2? What does it mean? He loses ₹2. When will he lose ₹2? If he throws an odd number. If he throws an odd number, right? So that is again 3/6, which is 1/2. Now I will put it in a table and see what exactly happens. This is x and this is pi. This is 5. This is -2. This is 1/2 and this is 1/2. What is the total probability? Total probability is 1. Therefore, x is a random variable. Therefore, x is a random variable. Okay. Also represented as a function on sample space of the game. That's what I've written here. So, if you see, it will exhaust the sample space, right? You can just put it like you see. This is like 2, 4, 6. This is 1, 3, 5, and it's a function. This will go to 1/2, and this will also go to 1/2. Okay, and this is very, very clear. This table is called probability distribution table. How did I verify that x is a random variable? Total probability should be 1. Okay. Now let's go to the next question. This is a coin is tossed twice and the outcomes are recorded. How many times you're tossing a coin? You're tossing a coin 2 times. The coin is tossed twice. Prepare a probability distribution table of random variable x, which represents the number of heads in the experiment. So x stands for what? number of heads. So what are the possible values of x? You can have no head, or you can get one head, or you can get two heads. Why? Because I'm tossing the coin only twice. Let us also have a sample space. Easy to write, right? Head, 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 tail, tail, head, and tail, tail. Now what is probability of x is equal to 0? Probability of x is equal to 0 means both are not head, no heads. So you can get tail, tail, which is 1 by 4. What is p of x is equal to 1? It's about getting one head. You can get head, tail, or tail, head. What is that? 2 by 4. I will never cancel and write it as 1 by 2 because I always wanted to maintain a common denominator which is easy for me to calculate. So what is p of x is equal to 2? Both are heads. What is both are heads? 1 by 4. Now that I completed, I will draw the table. Now what does the table indicate? The table will have xi, it will have pi. What are they? You can have 0, 1 and 2. And what are the probabilities? 1 by 4, 2 by 4 and 1 by 4. Is x a random variable? Let us check that. Sigma pi. What is sigma pi? If I total them, I get 1. Therefore, x is a random variable. It's always good to do it, to be very sure about that you have not missed out anything. Now he is also asking me to find the expectation of x, that is mean. So what do? You multiply this pi xi, multiply 0, then 2 by 4, again multiply 2 by 4. What is mean formula? E of x is nothing but sigma pi xi. So that is total of this, which is 2 by 4 plus 2 by 4, which is nothing but 1. So the expectation is 1. Okay, I hope this is clear to you. Let's go to the next question. In a manufacturing unit, from a lot of 20 baskets, which includes 6 defective, a sample of 2 baskets are drawn at random without replacement. These are the two important words: with replacement, without replacement. You have to be very careful with. Okay, find the probability distribution of the number of defective baskets. So first of all, what is the number of defective baskets? The number of defective baskets is 6. What is the number of non-defective baskets? Non-defective baskets are 14. A lot has 20, in that 6 are defective. So 14 are non-defective. So how many baskets I am selecting at a time? I am selecting 2 baskets. So X stands for random variable without variable. Probability distribution of the number of defective baskets. So X stands for number of defective baskets. So what are the possible number? You can have both the baskets. You are selecting 2 baskets. Both the baskets are not defective, or one basket is defective, or both the baskets are not defective. Clear? So now what is the meaning of X is equal to 0? Both the baskets that you have selected, are not defective. How many non-defectives are there? 14. And you are selecting it without replacement. When you say without replacement, the probability is going to change every time. So either you can do like 14 by 20 and 13 by 19, because I have not replaced it, so it has to reduce, which is a hassle for me. I am not interested in this. I prefer to do combination 14C2 by 20C2. I always use combination when you come across this word without replacement, which is effectively the same. Now, How do I calculate? We'll come to the calculation a little later. Now what is P of X is equal to 1? One defective, so one defective is where? This is one defective, 6C1, one non-defective, 14C1 by 20C2, out of 20C2. How do I calculate this? This is 6 into 14, because 6C1 is 6, 14C1 is 14, but what is 20C2? 20 into 19 by 1 into 2. This will go up, so you get 6 into 14 into 2 divided by 20 into 19. Now what is P of X is equal to 2? P of X is equal to 2 means both are defective. Number of defective boxes, right? Both are defective. That is 6C2 by 20C2. Now what is that? 6 into 5 by 1 into 2. It is there, okay? By 1, I can write 1 into 2. And what is 20C2? 20 into 19 by 1 into 2. So they get cancelled. So I get 6 into 5 by 20 into 19. Since I wanted to maintain a common denominator, if you want to, you can cancel 2 throughout, okay? 2 goes 7 times, 2 goes 10 times. Here again 2 goes 10 times. Here again 2 goes 10 times. Rest you can maintain as it is. So this is what? This is 91. I think it's 91 divided by 190. And what about this? 6 4s are 24. 284 by 190. And this is 15 by 190. Okay. So now what I do? I draw the table. I have Xi and I have Pi. 0, 1 and 2. So this is 0, it is 91 by 190, and this is 84 by 190, and finally 15 by 190. Now I want to find expectation, right? We'll cross check whether it is a random variable or not. Sigma Pi, what is that? This is 9, 10, so it's correct. 10, 20, perfect, it's 1, okay? So now you find Pi Xi. So Xi is a random variable, Pi Xi. This will be 0, this is 84 by 190, this is 30 divided by 190. So the mean is nothing but 84 plus 30 by 190, which comes to 4 and 11 by 190. If you want, you can further simplify it. You can divide by 2. That is your job. I'm leaving it to you. Okay. So 5, 7, 5, 9, 2, 18, 1, 5. Okay. I don't know whether 3 will go. Check it. Okay. That's it. And let's go to the next problem. The next problem is again, you have to tabulate it, okay? A class has 20 students whose marks out of 30 are given, okay? Marks looks low. If a random variable X denotes the mark of a selected student. So what does X stands for? X is marks of a selected students. So what are the different types of marks they can get? The marks they have got is say 14, and then I think we are having 17, 18 is there, 19 is there, 21, and then 25 and 26. 25 and 26. So what is the frequency? How many students are there? I have already counted and kept, so let us not waste our time. We can count and see. This is 3. I think I'm getting 5, 2, 3, 5, 2, 3, and then 3, 2, 2. So this way, you don't have to worry much. Okay. So total student is 20. 8, 10, yeah, it's 20. Perfect. Now, what is P of X is equal to 14? P of x is equal to 14 is basically 3 divided by 20. The number of students is 3 and total number of students is 20. Now what is P of x is equal to 17? X is equal to 17 will be 5 by 20. Like that you can do the remaining. Okay, let's draw the table. This is xi, this is your random variable, this is your pi. Okay, now what are the values? 14, 17, 18, 19, 21, 25 and 26. And what is your pi? Your pi is 3 by 20. And what's the next one? 5 by 20. And this will be 2 by 20. And the next one will be 3 by 20. And this is also 3 by 20. And this is 2 by 20. And finally this is also 2 by 20. That completes this. Okay. Now he wants me to find the mean. So prepare the probability distribution table. First subdivision is completed. Cross check and see sigma pi is 1, so x is a random variable. He wants me to find mean, so I have to find pi xi. Now how do I find pi xi? Okay. Let's see how to find pi xi. Multiply, you get, I have already multiplied and kept, it is 42 by 20, and then 85 by 20, 36 by 20, correct? 57 by 20, this is 63 by 20, this is 50 by 20, and this is 52 by 20. Now if I add them up, we'll come to that sigma pi xi. Okay, it is actually 385 by 20. This is my mean. I have calculated the mean, 385 by 20. So I am done with the mean. Now next I want to find the variance. So for that what I do, first I find xi square. Okay. Xi square. I square all this. Okay. So when I square all this, what do I get? 196, 289, 18 square is 324, 19 square is 361, this is 441, this is 625, and this is 676. Now you find pi xi square. So I want to find pi xi square, which is little lengthy. I am getting 147 by 20, followed by 289 by 20, followed by 162 by 20. Its calculations tedious, that's all. 1083 by 20. If there is any calculation mistake, please correct it. Okay, 1323 by 20. I can also be wrong with the calculation. 125 by 20, and finally it's 338 by 20. Okay, and the total comes out to be 7,689 by 20. 7,689 by 20. Now what is variance formula? Variance formula is sigma pi xi square minus sigma pi xi the whole square. What is sigma pi xi square? Sigma pi xi square is 7689 by 20 minus, what is sigma pi xi the whole square? 385 by 20 the whole square. Okay. Upon calculation, what do I get is I get 7689 by 20. If I expand this, I get 148,225 divided by 400. Okay. So on taking LCM, 400 is the LCM. I have multiplied and kept. So this is 153,780 minus 148,225. So when we subtract this, I am getting it as 5555 by 400. Okay, so this is roughly 13.9. So standard deviation will be square root of variance of x, which is square root of 13.9, which happens to be 3.7. It's only calculation and it is a little tedious. Otherwise, I don't think it's anywhere difficult. Okay. Now this is my last question. Okay, where I want to find a k value, and it's a very simple question. X denotes the number of hours a person watches television during a randomly selected day. Probability distribution, the probability of x taking value xi is given here. So what are the values of x? You can have 0, you can have 1, you have 2, and you have 3. And what are the corresponding probabilities? When xi is 0, probability is 0.2. When x is 1, you put xi as 1, so it will be k. When you put xi as 2, it will be 2k. When you put xi as 3, 5 minus 3 is 2, so this is also 2k. Now you know very well x is a random variable. So x is a random variable. It's given in the question. If x is a random variable, what do you know? Sigma pi is 1. Now what is sigma pi? Add all of them. It will be 5k plus 0.1, 0.2 equal to 1. So what is 5k equal to 0.8? So k equal to 8 by, this is 8 by 10 into 5, correct? I brought the k now. Now you can cancel. 2 goes 4 times, 2 goes 5 times. So the answer is 4 by 25. So my k value is 4 by 25. Is that clear? K is 4 by 25. That job is finished. So now what I do, what is the probability that the person watches 2 hours? So only 2 hours. So I want to find what is P of x is equal to 2. This is my second subdivision. P of x is equal to 2 is 2k. So which is 2 into, what is k? 4 by 25. So the answer is 8 by 25. Okay. So second subdivision is completed. What's the third subdivision? What is the probability the person watches at least 2 hours? What do you mean by at least 2? At least 2 hours means greater than or equal to 2. That is P of x is equal to 2 plus P of x is equal to 3. Now what is P of x is equal to 2? P of x is equal to 2 is 2k, and P of x is equal to 3 is also 2k. So it is 4k, which is 16 by 25. So the third subdivision is completed. What is the probability the watches at most 2 hours? At most. What do you mean by at most 2? Less than or equal to 2. Okay. The easiest way to do is instead of doing 0 and then 1 and then 2, you can do like this also. I prefer to do 1 minus P of x is equal to 3. From the total probability, you remove 3, you get less than 2, less than or equal to 2. So which is 1 minus, what is 2? The P of x is equal to 3, it is 2k, which is 1 minus 8 by 25. If you take LCM, what you get? 25 minus 8 by 25. It will be 9, 10, 11, 12, 13, 15, 17 by 25. So this is the fourth subdivision. Calculate the mathematical expectation. So he is asking you to find mean. Pixi 0, k, 4k, 6k, correct? 0, k, 4k, 6k. So what is sigma Pixi? It is nothing but 10, 11k. So my mean is 11k, which is 11 into 4 by 25, which is 44 by 25. Is that clear? Which is 44 by 25. Now finally I have to find what? Variance. So I have to do xi square, which is 0, 1, 4, 9. Now what is pi xi square? 0, this will be k, right? This is 8k and this is 18k. So what is sigma pi xi square? This is 26, this is 27k. Okay. So now variance formula. What is the variance formula? Sigma pi xi square, that is 27k, minus sigma pi xi the whole square, that is sigma pi xi the whole square, that is 11k. 11k the whole square. Now in place of values you can substitute. 27 into k is 4 by 25 minus 11k. I have already found the mean. Where is the mean? The mean is 44 by 25 the whole square. So this is 108 by 25 minus 44 square is 1936 by 625. LCM is 625. So numerator I will get after simplification. It is 764 minus, okay, I don't think so this is correct. It is 2700. This is 2700 minus 1936 by 625, which is approximately equal to 764 by 625, which is 1.22. This is my variance. So what is my standard deviation? My standard deviation is square root of 1.22, which happens to be 1.1. So that completes the problem. Okay. So with that, I have completed all the example questions pertaining to probability distribution from the NCERT handbook. We'll continue with this chapter and do further more problems from NCERT. First, we'll cover all the problems from NCERT handbook, including the example, because probability is a very important chapter. Later on, we'll go to ML Agarwal also. Kindly subscribe to my channel and click the bell icon to get notifications of all video. I hope these videos are very useful to you. See you again in the next class. Have a lovely day. Bye-bye. Thank you.